Great. So, a very good afternoon and welcome back, ladies and gentlemen, to today's final sharing session. The video displayed was from Virtual Science Fair 2021 sponsor, and we would like to extend our sincerest gratitude towards Kenanga Investors Berhad for your sponsorship for VSF's science exhibition. So, ladies and gentlemen, on behalf of the organizing committee, I would like to welcome you to University Malaya Science Exhibition brought to you by Virtual Science Fair 2021. I am Thinmuli Sekren and I will be hosting the event today. And we're currently in our third and final session for today, and we have a very interesting sharing session about the Pure Geology course. Thank you, Mr. Noor Muhammad, for taking your time to be a part of our event today. So Mr. Noor here graduated with a Bachelor of Science degree in Geology and a student from University of Malaya. So today, Mr. Noor will be sharing with us aspects of the final year project in the Pure Geology course at University of Malaya, as well as a presentation about his mini project. So Mr. Noor, the virtual stage is all yours.
All right. Thank you so much, Tainmuli, for welcoming me to this event, and I'm beyond honored to be presenting my mini research for Virtual Science Fair. Okay, so let me just share my screen for today's presentation. Okay. All right. Okay, so I believe that everyone can see my presentation, right? If you can see, please put up a thumbs up. All right. Okay, wonderful. All right. Hi, everyone. Thank you so much for tuning in for today's presentation slot presented by me. And also thank you to those who are also watching on the YouTube live stream as well. So today's presentation slot is going to be pure geology. So I'll be talking about my mini project, and I'll also share some of my experience in doing research project in geology. All right. So Tinmuli has already introduced myself, but it's okay. I'll just give you a brief introduction about myself. So my name is Noor. I recently graduated from University of Malaya with a degree in geology. And these are my past experiences. I worked as an intern at Petronas, and now I'm currently working as an intern at a social enterprise in Malaysia called Undi 18. Right. So to set the tone for today's presentation, we'll be covering three interesting segments. So first, I'll be talking about my mini research project that I've done with my colleague. Unfortunately, my colleague couldn't make it today. So just a shout out to Paco for helping me do this presentation, for helping me do this research with me. So the research is entitled Coalseam Fire, and these are the subtopics that will be discussed. And followed by, we'll be talking about the research stages in FYP preparation, especially for geology. And then finally, we will close off today's presentation with a quiz. So I hope everyone will be staying until the end to answer some of the easy general geology questions. All right. So my topic for today is coal seam fire, or I like to personally call it as a burning problem underneath our feet. So before we dive into the topic for today, I think it's appropriate for me to introduce everyone what coal is in general. So coal is basically a sedimentary rock in geology. Basically, sedimentary rock is a rock. It's a rock as a result of the accumulation of of eroded materials from former rock. All right, and these coal are basically composed of decayed plant organic matter. All right, and decayed matter, and it's because of that it contains high amount of carbon and hydrogen. So it's basically a hydrocarbon material. So, since considering it's a hydrocarbon material, so it's no surprise that coal is actually a combustible substance. right? And it's also distinguishable by its black or brownish black appearance. And as you can see on the right-hand side, so that's how a coal will look like. So this is just an example of one particular type of coal, right? And below you can see how coal was formed throughout the time. I don't think I will be explaining about this because it's pretty much straightforward. So basically, it is a rock made from decomposed plant matter. So when these plants decompose, they will get buried deeper and deeper into the earth because of the overlying sediments on top of coal. And as you go deeper, pressure and temperature will rise undeniably. And as a result of this heat and pressure, this accumulated sediment will then turn into coal through the process of coalification. Okay, next, so now we've already understood what coal is. So now it's also appropriate enough for me to introduce everyone what seam is actually. So coal seam are basically dark brown or black banded deposit of coal that is visible within layers of rock, or I would say a coal bed. So because in geology, there's this one unique characteristic about coal where coal can be found continuous along a bedding. All right. So because of that feature, geologists tend to call coal beds as coal seams. All right, because of this characteristic, and it's because of this extensive nature of coal that is why coal is often cited as a good stratigraphic marker. So when we do correlation between beds from one location to another, so if you have coal, it makes things much easier for geologists to correlate. So now let's go deep into what coal seam fire is. So coal seam fire is basically a slow process of self-heating of coal or other materials that contains appreciable to significant amount of carbonaceous material. Their other name is also known as spontaneous heating or auto-oxidization. So basically what this means is that these coal seams, they are not intentionally heated or oxidized. So it's basically an indirect thing where basically it happens without the intention of any it doesn't involve any intentional heating basically. And I will be talking about why is it spontaneous in this case. And third of all, coal seam fires occur mostly in operating coal mines and abandoned coal mines and finally waste coal piles. So next, we'll be talking about the general mechanism. Okay, now we understand what coal seam fire is. It is a spontaneous heating of coal. But the question in hand is, how is coal heated without any intervention? So I'll be talking about a general mechanism here. So the general mechanism of coal seam fire is that, okay, for example, you have a bedding. So this is what we call as a bedding here. Let me just use my laser. Okay, so I hope you can see my laser here. All right, so here you can see this is a block diagram. So we have sandstone, mudstone, coal, and mudstone. So this is basically a simple example. All right, so when people find coal, right? So the next natural step for humans to do is that to excavate them. So to excavate coal, there are lots of ways to mine, right? So there are different ways, but for this example, I'll be using the open casket method, where a huge chunk of the earth is being dug out, so the underneath is just being exposed to the atmosphere. All right, this is just a simple example. So when this happens, right? So coal is exposed. All right, now it doesn't have the overlying sediments on top of it. When it's exposed, oxygen comes into contact with this coal. And remember, when you have oxygen, anything that has with oxygen and something, right, or any material, right, naturally the process of oxidization happens. But this happens without the aid of heat. So remember, it's a slow process of oxidization. So here what happens is that the top surface of the coal here will be subjected to oxidization. And when it's subjected to oxidization, coal decomposes slowly into several byproducts, mainly carbon monoxide, carbon dioxide, water vapor, and heat. Okay, so heat is basically the most important part here, so which I will be talking about later, which will be the next block diagram. So usually, since heat is produced in this situation, but in the initial stages or the first few hours of oxidization, the temperatures are pretty much ambient or low, so it's not that serious. But as this process goes on, let's say if it's been excavated already, but then it is not filled up, meaning that this particular depression here, there's no filling here. So basically, it's left just like that. So what happens is that oxidization still continues, and when it continues, remember, you are accumulating heat. So sometimes this heat, right, cannot be assemblaged or cannot be diffused out from the coal. So heat is trapped within the coal. So remember, if time goes on and on, this heat will be multiplying. No, I mean, it won't be multiplying. I would say the temperature would be increasing, all right, continuously. And when the temperature increases, the local temperature of coal will also increase and may reach high temperatures up to 70 to 85 degrees Celsius, which is really high. Or in worst case, it may go up to 100 degrees Celsius. So as this process goes on, coal will then reach a critical point temperature, where it's the temperature where coal starts to ignite. All right, remember, before this, the coal is not being ignited, it becomes smoldered. Smoldered as in like, imagine you have an incense stick. When you burn your incense stick and then you blow it away, you can see the smoldered red part, right? So that's what I mean. It's smoldering. It's not burning, basically. So when it reaches that critical point, it starts to ignite and combust. And when it combusts, all right, so remember, carbon is extensive, like I mentioned. It extends farther out. So the fire will start to spread out continuously. So thus giving rise to what we know as Coalseam fire. Okay, next, let's take a look at the global overview of Coalseam fire. So Coalseam fire is proven to occur in several countries worldwide, especially with countries that have significant coal deposits like America, USA, China, Australia, India, South Africa, and even in Southeast Asia region, especially in Indonesia and also Malaysia, which will be discussed later. But I would like to bring your attention to Pennsylvania, USA, where this is the place where it's pretty much close to our case study that we'll be discussing later, which is Batu Arang. So Pennsylvania also has significant coal deposits back in the day, but now they are facing a rather treacherous tragedy, I would say, of Coalseam fire because of this particular decision made by the authority, which is very similar to our case study, which is going to be discussed later. And I won't be disclosing what happened in Pennsylvania, and I'll be unraveling the information soon. Right? Continuing on, so our case study for today is Batu Arang, Selangor. All right, just to give you a rough idea where Batu Arang is. So Batu Arang is a town in the district of Gombak, and it's located approximately 50 kilometers from the capital of Malaysia, Kuala Lumpur. So as the name suggests, so Batu Arang used to be one of the biggest, I would say, the center of Malaysia's coal mining industry that began to blossom in 1913. All right, but then after 47 years, its coal mining operations ceased due to political turmoil and local social problems that arose. So because of that, coal mining was then operations experienced cessation, and now it is no longer operating in Batu Arang. So it's basically a town that has several abandoned mine pits. So now, whenever we talk about any geological topic, it is also customary to talk about the general geology of the particular area. So I won't be talking much about this area, but I would like to bring your attention to what are some of the sediments, I would say, or rock that are present in Batu Arang. So first, we have the Quaternary sediments. So Quaternary refers to a geological time period where it spans from 2.6 million years ago until 11.7 thousand years ago. So usually in the Quaternary sediments, it consists of very loose clay to sandy type of sediment. So it is basically not a rock yet. It's basically a sediment that is loose, macam pasir. So basically it's like that, but it also has clay. And then continuing on, we have the tertiary sediment, the tertiary beds, which span from 65.6 million years ago to 2.6 million years ago. And it consists of boulder beds and also coal measures. So this is what we call as a satellite map. So now what we do in geology is that we always superpose the satellite map with our geology map. So the geological map looks something like this. So basically, this is what we do. We identify what type of bedding is present in that area. So we have the boulder beds here, which is the polka dot. All right, I've labeled here nicely. And we have the flooded mines. Remember, I said that Batu Arang is an abandoned mining area, right? So there are lots of places or locations where you'll find mine pits that are often flooded, you know. And finally, there are also coalseams present in Batu Arang, where it is represented by the black line that runs through the peripheral section of Batu Arang. Okay, I hope that's clear enough. So next, we'll be looking at the cross section. So it's also another important aspect. So without looking at the geology from the plan view, it is also important to take a look at what's beneath the ground. So this is what we call as a cross section view. So cross section view, we'll try to look at the cross section view to understand how is the geological setting like. So sedimentary rock, they require what we call as a basin or a depression in layman terms. So for instance, if you want to eat curry laksa, so you need to have some sort of like material that could hold, right? So that's what we call as, something that can hold the sediment. So that's what we call as a basin. So, Batu Arang also has that depression-like basin here. And then just to make, so this is what we can see if we do cross-section. But to make it easier for the viewers, I've also done a block diagram to represent what you're looking at. So basically this block diagram is representative of this one, but I didn't take into account of the inclination. This is just to give a rough idea of what type of rock or bedding you will find. So BB means boulder beds and CM means coal measures. So it's pretty much straightforward. So now continuing on to the next part, which is the most important part, which is the occurrences of coal seam fire. So just like in Pennsylvania, Batu Arang has also been a subject of coal seam fire, throughout the years. Okay, so coal seam fire firstly occurred in Batu Arang at the location of Kampung Melayu Tambahan, which happened in 1996. But then after I would say 15 years, I would say, yes, correct, 15 years. So the same tragedy happened in the same area of Batu Arang, but it's located 1.6 kilometer away from Kampung Melayu, which is in Bukit Nanas. So there's a gap of 11 years there, and we don't know why it happened, right? So, Batu Arang has also been in the tabloid, for experiencing such tragedy. But looking at this news excerpt, right, the reason why myself and my friend chose Batu Arang as our study area for coal seam fire is that even though there were reports of coal seam fire here, but there were not much of research being done to decipher what's really going on. And we felt that it would be appropriate for us to choose Batu Arang as our study area to further understand what's the reality like. All right. So now the objective of our research is to find what are the factors. So I've explained the mechanism, right, of coal seam fire. So it happens because of oxidization. But oxidization is just a general factor. But there are also other factors that can result to coal seam fire, and we want to get close to the truth. So, but then since there's not much of research, we had to rely on the methodology of interviews. So we interviewed a few people in Batu Arang. So we have 2 residents and also 1 expert. So JMG Perak means Jabatan Mineral and Geoscience, which is a government body that deals with geoscience matters in Malaysia. So we interviewed them, we asked them about their experience, what was it like, living, what was it like experiencing such tragedy in Batu Arang, and trying to get their answers, like what could be the possible reason. So after we interviewed, we found out that 3 interviews had one answer, and they had one answer in common. All right, so all 3 of them said that Batu Arang reported multiple cases of open burning and land clearing activities. And all 3 of them, they think that maybe this has close ties to the occurrence of Coalseam fire. But remember, I said that Coalseam fire is basically a spontaneous heating. All right. So sometimes in certain cases, you will also find where Coalseam fire happens due to intentional heating, but then without the prior knowledge of the residents. So since we have a hypothesis, okay, now it's open burning and land clearing. So now the most appropriate thing to do is to find out what could be how true. I mean, what's the how do I say this? We want to justify whether is it true or false. So now talking about open burning. So what we did was we compared. We tried to look for information that where we can compare. Is it true that Batu Arang or Selangor in general, it experienced extensive open burning or land clearing activity. So we looked at information from the Forest Fire Journal, and we noticed that throughout the years, Selangor has been cited as a hotspot. Has been cited as a hotspot for open burning and land clearing activities. And these land clearing activities are usually done in peat swamp forests. Remember, coalseam fires always occur. They always occur. I mean, not coalseam fire, but coal in general. You can find it usually in peaty swamps, because that's the location where you get lots of input of dead organic matter. So we can see a correlation there. Okay, so we can see that peat swamp forest is where open burning happens. So we can do a preliminary deduction. I wouldn't say a conclusion. It's more of a preliminary deduction where we can say that okay, maybe coalseam fire in Batu Arang could be caused due to open burning, but then we don't have enough data to justify due to our limited resources, and we don't have the needs to conduct this research. But if you see in other countries, people have started to do simulation to better understand what is it like, of coalseam fire. So now, let's say if coalseam fire happened due to open burning, so we want to justify how could this be. So this is just a proposal or just a suggestion, or I would say, from myself and my friend, where we believe that usually open burning or land clearing activities involve combustion of any materials, right? So firstly, what happens is that in this condition is that trash, right, or trash or any material, when it's being burned, okay, on top of ground where it has appreciable or significant coal deposits. So this heat from the trash, it will then be transferred to the coal below. So remember, when your coal is being subjected to heat, what happens is that it starts to become, remember, coal is an important fuel. Okay, it's an important fuel, and if you give the slightest heat, it will then become smoldered. All right. So after a while, when this heat prolongs, the coal will become smoldering red, and eventually eventually spreads this smoldering effect to adjacent coal seams because of its extensive nature, right? So it has access to the adjacent coal seams. So remember, heat here are not being assemblaged or it's not being escaped. So it's being trapped. So when the temperature increases to a certain point, it will soon catch fire, and then it will spread farther from the source. And that's how coalseam fire could have happened due to open burning. So this is just a hypothesis that we believe could be, but we need to have strong data to justify this. We need to do lab work to confirm this. But due to the limited resources and limited time for this research, we only had to settle up for this hypothesis. All right. So now I can see one of the questions is that, how dangerously does the seam fire affect the neighborhood? So I think this would be the section where we'll answer your question. Okay. So basically, some of the palpable effect of Coalseam fire is release of toxic gases. Okay. So so basically, right? Remember I said that oxidization, it releases gases like carbon monoxide, carbon dioxide, and stuff like that. So similarly, when you heat, you will tend to get more toxic gases being released because of the nature of fire being a catalyst, in exacerbating the oxidization process. So you tend to get gases like carbon monoxide, methane, carbon dioxide, and then that may cause respiratory problems. So, and also, right, since it's a burning problem, definitely Coalseam fire will increase local temperatures. So from our interview with Mr. Robert, as you have met him from the previous slide. So here is where from Mr. Roberts' point of view, he even said that he experienced, the ground being heated up to the point of 40 degrees Celsius. So imagine that 40 degrees Celsius of walking, you're walking on the ground that is 40 degrees Celsius. So it's basically like you're walking in an oven. So that's one of the effects of Coalseam fire. And finally, it also affects lands and also it affects lands and buildings, all right? So what are the current mitigation plans are being done is that, now authorities Batu Arang, they are relying more to dousing hot coal with water, meaning you put out the Coalseam fire with water. Even though it is an effective way of putting out fire, but scientifically speaking, it's also hazardous because it facilitates or it fastens the emission of other toxic gases. So this is pretty much analogous to having a hot pan. Imagine you have a hot pan and then you throw in water inside a hot pan. So what happens is that it vaporizes, right? But in that hot pan situation, you only get water vapor. But in coal, you have other chemical constituents. So when you douse them with with water, so it will tend to release other gases that could be harmful for people living above. Okay, and then so after realizing this downside of dousing, after seeing the downside of this particular plan, so the resident have opted to use sand blanket, where they will pour sand over the hot coal to put out the fire, and it's a cheap and safer way. So now we've already finished Coalseam fire. So now we're moving on to the second segment. So it's going to be super fast for this one. I'm not going to be taking too much long time here. So we're talking about the 5 research stages in geology, geology-based FYP. So we'll start off with the desk study. So desk study is the first step. So basically what you do in desk study is that you try to get information, as much as information as possible, before preparing your proposal of fieldwork for your research. So usually what happens here is that you will tend to look at literature reviews, you will tend to look for information from past research papers that may help you complement your research. Okay, and some of the examples, some of the examples of previous work that are usually used in this stage is article journals, ebooks, and research papers. So in geology, the green book that you see here is our holy grail, basically. We use this book for everything because it's always complete. So that's basically our top priority when it comes to looking for additional information. And these are some of the other platforms where you can also get your research papers. Continuing on, the fieldwork. So fieldwork is basically the most awaited part of the research, where students will do a site visit to the outcrop of the study area. So what we usually do in fieldwork is that we try to gather as much raw information as possible to better understand your their outcrop, right? So some of the information gathered or some of the materials gathered include samples of rock samples, strike and dip. So basically strike and dip is to non-geology people. So strike and dip is basically to measure the inclination and also the direction at which the bedding are facing, okay? And also we do outcrop sketching. So when we're in outcrop, the only best way to to get the picture of the outcrop is by sketching it. People tend to take pictures, but pictures usually don't do justice to the outcrop. So we do sketching. So this is just an example of pictures that I've taken for my research. So this is an example of a geological structure where we call it as a fault. So you can see that one body of the rock is sliding downwards, and this one is basically stationary, but if you look at the relative movement, one is going down, one is going up. So this is what we call as fault. And then this is part of my FYP, but I'm not going to be talking much about this because this will be taking too much of your time. Next would be lab work. So after you have collected all this information, the next thing that you would do is to analyze this information. And these are some of the analytical geology laboratory techniques that I have used for my FYP. One is X-ray diffraction, ion chromatography, and petrographic analysis. So what happens in XRD is that we will crush the rock samples into fine powder, and then we will run the X-ray machine to analyze what type of minerals are present in this rock sample. And then for IC analysis is where we dissolve rock, or maybe if you have a water sample, we are trying to analyze the anion concentration in the particular sample. And finally, petrography is basically taking a rock and making thin sections. And after you've completed thin section, we view it under the microscope. So that's basically about petrographic analysis, right? So now moving forward, the fourth stage is seminar. So seminar is the most, I would say, from my experience, would be the most nervous stage, I would say. So after you have collected enough, after you've been through fieldwork and you have done laboratory analysis, so at this point, you should have enough information ready at your fingertips. So then this is the point where you will need to proceed to the next stage, which is seminar. So during seminar, you will need to present your findings and your inferences that will be attended by your supervisor, readers, lecturers, and students in general. So this is where they will try to understand what's the progress like of your FYP, and there'll be a follow-up Q&A to understand. And then next one, the final one is pretty much simple. I'm not going to be explaining. It's basically thesis writing and submission. So this is an example of my thesis that I've done for my university. And yeah, and just for your information, there'll be two more stages actually, but I did not include here because I find that in general FYP research, for geology, if let's say you're an independent person doing research, usually you won't be going through all this initial viva, final viva, but this is more strictly for students. Okay, so what happens in initial viva and final viva is that you will update your person in charge, not person in charge, I would say, sorry, your supervisor and your readers about your progress, and then you will show your findings, and you will tend to get their advices, like how can I make my research even more impactful. So that's the whole point of initial and final viva. So initial viva usually happens between stage 2 and stage 3, and final viva happens or occurs after stage 5. Okay, so I think that's all about the FYP stages. So now, all right, so this is the most fun part. We'll be doing a quiz. Okay, so just to set a tone for the quiz, I will be showing you some questions, some general easy geological questions. I'm not going to be probing you with technical questions where you need to do calculation. No, we won't be doing that. So it's pretty much straightforward. I will be presenting the questions to you in this slide. And please make use of the chat section in the live stream or the YouTube live chat section. And please drop down your answers below, and then I will see which options are you guys choosing. So basically, this is a MCQ, all right? So no worries. So if you're ready, so this is your question 1. So coal consists of high concentration of which two elements, A, B, or C? I think I already covered this in my presentation, so hopefully let's see what the participants are answering. Okay. All right, no answers. Okay. All right. Okay. So there's someone saying B. Someone said B. Okay. So quite a number of people are saying B. Okay. All right. I see A. Okay. Okay. I think. All right. Okay. So the correct answer is drum roll. Okay. The correct answer is A basically. So I've already explained this. Coal has high concentration of carbon and hydrogen, even though it has oxygen. But if you compare it relatively with carbon and hydrogen, both of this element wins lah, basically in this case. All right. So okay, now continuing on to the next question. So what is the name of the large supercontinent that existed 200 million years ago when all of the continents were together? All right, so A, B, or C. I think this is pretty much easy to understand. I think this question was also asked in the previous slot. So hopefully those who attended might be able to understand, might be able to answer this. So I'm seeing C, 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 and some said they had name. Wow. Right? Okay. So yes, okay. So by looking at it, definitely we know the answer is C. So San Andreas is basically the name of a fault that is located in, that runs along the length of California. So yeah. Next is, okay, so coal is developed extensively along the equator at which time in the geological time scale? So this one's a bit difficult to answer, but I've already given you a hint. So I hope the hint is easy to, will be very helpful for you in answering this. So is it A, Cambrian, B, Carboniferous, or C, Triassic? Okay, I'm seeing C here. Okay, I'm seeing B. Okay, anyone else answering? If not, I can think, all right, okay, I'm seeing lots of B. So the correct answer is B, well done. So it's carbon, so remember that, Carboniferous. So that's why. So Cambrian and Triassic, there are other geological timescale in, they are important as well, but definitely coal production peaked in Carboniferous. Yes, correct, because coal's got carbon. Well done. Next is, what are the layers of the Earth in order from the inside to the outermost? So this one, try to use your logic. This one is, by looking at this name, you guys will know. Okay, remember that we're looking from the inside to the outside. Okay. Okay. All right. Am I seeing any answers? Okay, I'm seeing C. Okay. All right. I'm getting lots of C's. Okay. Well done. The answer is C. Okay. So, and this is just the justification why it's C. So it starts with inner core, outer core, mantle, and crust. And then this is the fifth question. What mountains separate Europe from Asia? Is it A, Himalayas, B, the Andes, or C, the Ural? So this one, you need to use your geography knowledge. Okay, I'm pretty sure you guys have heard of these names from geography. So try to think of it. Where is it located? And does it make sense or not? Does it separate Europe from Asia? So I'm seeing A, okay. Anyone else want to wager a guess? Someone saying A, I think it's A. All right, anyone else wants to be different? Want to go for like B or C? Okay, someone said C by Farhana. Okay. All right, so the correct answer is, it's C. I know that, many people would think it's the Himalayas, but just to justify just to answer your confusion, so the Andes is located within South America, so it's not really separating any continent. And then when you see Himalayas, so Himalayas is basically located still in the Asian continent, so it hasn't left yet. So it's not Himalaya. So the correct answer is the Ural. The Ural Mountains is located in between Asia, close to Russia, and and it separates Asia from Europe. So C is the correct answer. And finally, the last question. What percentage of the Earth's water is drinkable? Okay, so this will be interesting to know how people will answer this. So try to come up with a guess. Let's see if you are lucky to find the answer. So I'm seeing 1%. Okay. Someone said C. Okay, 1% as well. I'm seeing B. Okay, that's interesting. 1%. Okay. So I think, okay, so the correct answer is indeed 1%. Okay, so this is because the world's water distribution, it consists almost 97% of ocean water, which are salt water, and the remaining 3% are fresh water. But among this 3% fresh water, you can see that the amount of accessible surface drinking water is only 1%. All right, so that is why the answer is 1%. Okay, so with that, I conclude my presentation for today. And before we go into the Q&A, I would like to get your kind cooperation. So I am doing this one project with my friend, helping him with this advocacy project, and we're trying to get as many people to answer our survey to better understand the financial literacy in university students. So I thought it would be appropriate for me to share this with the people attending for today's session. So it would mean a lot to us if you could answer the survey. So the link is located here, the bit.ly. So, and you may also scan the QR code here as well. So every feedback from all the participants here today will be much appreciated. So with that, I conclude my presentation for today. Thank you. All right, so I think now will be the Q&A session. So if you have any questions with regards to my presentation, feel free to use the chat section and I'll try to answer as much as I can. Okay. So I think, all right. Okay, so how dangerously does seam fire affect the neighborhood? Can it cause fatality? So, by looking at the effect just now that we discussed, so definitely it does pose a health threat to the people living above, especially when it comes to respiratory problems. So in the first few, if you're exposed mildly to the situation, definitely you won't be impacted seriously, but you'll be impacted slightly. But in the long run, if you're still living there, and if you're still experiencing multiple accounts of coal seam fire, then definitely your life will be jeopardized due to the toxic gases and also the inconduciveness of the environment. Hope that answers your question. But fatality, I haven't heard in the news so far. So because it's a slow process, so people might, they might get a warning, from authorities to evacuate, so stuff like that. Yeah. Since the induced heating hypothetically can smolder the coal, can the hot weather lead to the smoldering of the coal too and causing coal seam fire? Absolutely, definitely, yes. If we look at certain countries, right, where it receives sunlight, 12 hours, like example, like Malaysia, along the equator. So definitely if you have exposed coal, right, and if the weather condition is extremely hot and it's exposed just like that, remember that if you have oxidization and you have heat, so this heat will act as a catalyst to further exacerbate the situation. So to answer your question, yes, definitely weather also has a direct influence in resulting to coal seam fire. What about cations? How can we detect their presence in water sample? Good question, Gabriel. Okay, so I talked about ion chromatography. So ion chromatography is basically a a laboratory machine that helps one to identify what are the anions present in the rock sample or in the water sample. But if you want to take a look at the cation sample, there's also another machine for that, a special one. It's called a ICP-MS. If I'm not mistaken, it's called Induced Coupled Plasma Mass Spectro something. I'm so sorry. Maaf for that. But yeah, its abbreviation is called ICP-MS. You may Google it. So it's basically a bigger machine compared to the IC. So what does ICP does is that it analyzes the concentration of the cations present in the sample that you wish to analyze. Okay. Next question. Any tips on seminar presentation? Okay, so when I look back at my seminar presentation, I would say that I was slightly nervous when it comes to presenting your ideas, your findings, because you don't know how people would reciprocate your findings. Is it acceptable or is it denied? But what I would say is that remember that my experience is basically restricted to geology. So if you're a geology student, so this would be very useful. Remember that geology is not a defined subject. It's an ambiguous discipline that does not have a right or wrong answer. So you are put in a position where you may freely express your findings, and if you have the correct justification that can help you complement your findings, then it will be really good. So I would say that you need to be confident in yourself while presenting and make sure that you know what you're saying, because in science generally, you must make sure that you have to be precise in what you say. So if the slightest, for example, if you say something otherwise, so definitely you'll be put into a position where you'll be questioned. All right, you'll be. I would say, in our in our youth slang, I would say like you get attacked, but it's not more of an attack, but it's more like you're being probed with that question. So I would say try to practice as much as you can and make sure that you say the correct things. Hope that answers your question. From the quiz session, geology seems interesting. How about dengan FYP? Was it so deep and complex? All right. So for this purpose, right, the reason why I didn't want to present my FYP is that it's too much to take into. It's about I need to also look at my target audience. So that's the whole point of presentation. You need to tengok your audience, like, are they from geology? Are they from other disciplines? Just to make it more inclusive. So I thought of choosing a topic that I did previously that is much comprehensible. So yeah, but if you're wondering what's my topic is about, so my topic is basically about secondary sulfates. So remember the picture that I showed you where it has a rock and then it has that yellow patch. So that's what we call as secondary sulfate. And my FYP was to classify the physical and chemical characteristics of secondary sulfate. So that's why I didn't want to talk more about that. It's going to be too much to absorb. So I resorted to an easier one. Hope that answers the question. Any tips on how to come up with interesting topics to be researched on for FYP? All right, so usually when it comes to choosing a topic, I forgot to mention this one part in the FYP research. In FYP research preparation, it's important for you to choose a supervisor, because the supervisor is the person that will be solely assisting you from day one until the day that you finish your FYP. So usually what happens is that in certain universities or in certain according to people's preference, usually people will tend to go for what the supervisor suggests. So usually the supervisor will suggest a few array of topics and you can just choose the topic that best represents your interest. But in the case, if you want to talk about interesting topic to be researched on FYP, this one I can talk more about my Coalseam fires research project, because this research project I was not told by anyone to do it. So it's something that I and my friend did it on our own accord. And how did we find this topic is that I was drawn to coal back then. So I want to do something that talks about the energy sector. And I came across with Batu Arang, and I know that Batu Arang used to be a a center for coal mining. And definitely, by if you over, I mean, if you go beyond history, you also tend to find lots of interesting stuff. So what I did was I googled geological problems in Batu Arang, like what could be the reason why it abandoned. But instead of finding for the reason for abandonment, I found another topic that's quite interesting, which is Coalseam fire. So usually, right, you need to figure out what type of topic you want to go for. It has to be your interest. It has to speak. I mean, it has to be a topic that speaks to you. All right. So if you have the topic in hand, and if you do your research study properly, if you do your preliminary studies properly, then you will find a lot of topics that are interesting that sometimes you may not even know. So yeah, hope that answers your question. Any advanced sensor for the detection of coal seam fire and how it can be prevented? Usually, I don't think there are advanced sensor because this is underground. So definitely, if you do like seismic surveys, or I'm not too sure whether will it show up seismic survey. So basically, for those who are not from geology, seismic survey is basically like in layman terms, it's basically geologists performing an X-ray for the underground. So I don't know if seismic survey might show up incidences of coal seam fire, but how it can be prevented, I think you can learn from how Pennsylvania is handling right now. So the town that experienced coal seam fire, so they already know that that this problem is prevalent and something that can't be avoided, because they have lots of coal deposits there. It's just that it's easy for the coal to catch and fire. So what they do is that they do a system where it allows them to draw the heat away from the coal. So that's why you can see, like, if you Google the town Centralia in Pennsylvania, you will see lots of pipe that emits vapor. So those vapor are actually from the coal down there. So when these vapors are released, so the heat cools down. I mean, the coal cools down, and then this will slow down the process of coal seam fire. So I think that's something that we can try to adopt. But in terms of monetary, I mean, in terms of monetary, definitely it will incur lots of costs. But by looking at the positive results, I would say that indeed it's a good investment that Malaysia needs to look into. Hope that answers your question. I'm actually curious on how you do actually detect underground phenomena like CSF. Do you collect samples, or is it entirely predicted via mathematics? This one's a bit deep, I would say. But usually, like I think it was similar to the question before. So definitely, there's no sensor or there's no way to detect it unless you experience it. Unless you're a resident like Mr. Robert. When he lived there, he noticed that as the days goes on, the local temperature starts to rise too much and becomes unbearable. So that's an early sign, basically, that something might be wrong. It may not be the temperature, but it may not be the weather, but it could be the underlying coal seams. And predicted via mathematics, I think there are research where they're trying to what do you call that? They're trying to numerize this situation. They're trying to get numbers to help them predict this. And I think that one, since you brought up mathematics, right? So I need to talk about also data science, definitely. So definitely, if geologists were to come up with a simple algorithm or a simple framework that can help them with the incorporation of data science, definitely the process of detection and censoring it might be, a reality someday. So hope that answers your question as well. Is there any alternative for fracking? Is it harmful to underground water? Okay, so this is a bit different from Coalseam fire. But for fracking, as it is harmful to underground water because fracking is basically okay. So from my experience, from my knowledge, I understand that fracking is usually done for extracting hydrocarbons from below. So basically, what fracking means is that because these oil are trapped inside the bed. So when they're trapped inside the bed, you want to break them open so that the oil will come out. But what's the downside of fracking is that the fractures can extend all the way along along the bedding, and this may come into contact with underground water. So definitely, yes, it does pose harmful side effects to underground water, but I am not too sure about the alternatives yet for fracking. I mean, there is, but there could be one, but I'm so sorry, but I don't think I have an answer for that. But just generally, fracking does pose a serious threat to the pollution of underground water. Right.
All right, great. So I believe that's the end of the Q&A session. So thank you very much, Mr. Noor, for your very insightful presentation about your mini project. And I hope your sharing will come in handy for many potential geology students. And Mr. Noor, would you like to add a couple of things before we end the session today?
All right, just want to say thank you so much for everyone who participated for today's session. I did see a few familiar faces in the comment section, so thank you so much for supporting me. And I hope that all of you have found it really informative. And for today's session, if you have any further questions, please do reach out to my LinkedIn profile. So it's basically my name, Noor Muhammad. You can just Google it there, or if you want to make it more specific, you can just put Noor Muhammad Geology, so it will just come out. So you can just find me there, and then you may ask your further questions there. So thank you so much.
Yes, that was very great. Once again, thank you for your time and the effort you've put into your sharing session today. And as for the audience, thank you very much for tuning in with us today. And once again, kindly fill up the feedback form uploaded in the live stream chat because your response will be counted in choosing the winner for our best presenter. And we humbly thank you all for tuning with us today and for having the curiosity to learn more about the academic opportunities provided by University of Malaya. The organizing committee is very grateful for your presence today, and we will see you tomorrow at 9 a.m. with undergraduate mathematics and biology final year presenters, as well as a master's research presentation. And yes, I will see you again tomorrow at 9 a.m. So take care and stay safe, everyone. So, and for Mr. Noor, we have like a very quick photo session. So, your brightest smile, please, so that we can get a great picture as a team.
Okay, all right, everyone ready?
Yes.
Okay, give your brightest smile. Give your brightest smile in 3, 2, 1. Okay, wait a minute. Another one in 3, 2, 1. All right, thank you.
All right, great. Thank you so much.